wear your helmet and ride a bike because you don't know when people are going to ride or are going to run red lights that hit you going 45 miles an hour. And always wear your helmet. So my name is Steve Levy, and I'm the Vice Dean for Academic Affairs and Chairman of the GE program. So if you have any complaints about the GE program, send it to Richard Flegel, not to me. I want to introduce our panelists. These are great professors. Jefferey Sellers from political science, who specializes in policy areas of the environment. Sarah Feekins from earth sciences, who is just an amazing scientist who focuses on the climate issues, but also on other environmental issues dealing with the earth as well as the sky. And then, what's his name? Julien Emile Geay, who is also a wonderful scientist who actually is in charge of our Abrams Committee on Climate Climate Science in our Abrams Lab, which we have over in their building, which we just put together and working on this new climate science minor. So these are three fantastic professors who are doing work in this particular area, and it's their time.
Okay. Great. So what we're going to do is start out with each of us giving a little bit of an introduction to how we see our sort of discipline and our research is relevant to climate change and what we think is going on. We have three questions that we've decided to focus on. First of all, we'll give you a little bit of an overview of what the science of climate actually tells us and what the current scientific consensus holds, as well as what the science shows about what needs to be done, which is, I think, a much more difficult question. We'll probably add in some about some of the research that we have ongoing in earth sciences about previous periods of climate change and what that seems to show about what is happening now and what will happen. And then finally, we want to get around to this main theme of the Electoral Commons series, and that is what is at stake in the current election. Could be the presidential election, but of course the national election for Congress as well. And I believe this is actually an important election for the future of climate policy in the United States. And perhaps we'll watch. So we'll get into all these questions with some brief presentations. We'd like to leave enough time for as many people as possible to ask your questions, and if you want to participate as well with your own arguments, and if you want to challenge some of the things that we say.
We have a microphone for you.
And so we'll only ask if you stand up and have something to ask or say, if you would also identify yourself and just tell us a little bit about your background, your major, or what your interest is in this area. So, but we will talk briefly, starting with Julien.
First of all, can you guys hear us?
Yeah.
Yeah? No need for microphones? Okay, good. At least not listen. So, climate is obviously a politicized issue. It's not entirely obvious why that is. Well, at least it wasn't obvious to me until relatively recently. There's lots of other science issues that inform public policy, but it's hard to think of one that has achieved that level of controversiality in the public discourse in this country in particular. It happens to a lesser extent in others, but in particular in this country, it seems that there's a very strong alignment that whether you believe the science of climate change, you're much more likely to be aligned with the program of the Democrats, and vice versa. If you don't believe it, it's very likely that you're somewhat on board with the agenda of the Republican Party. So that is a somewhat unfortunate state of affairs, because as scientists, we would like to just be able to offer the facts and then let society make informed decisions from that. But when there's a good 50% of the electorate, or hopefully a little less, that just does not want to accept the facts, it makes that a little difficult. So we thought that we'd start with some of the facts, and then we can talk about where we go from there and how would that translate into policy. How many of you doubt that the Earth is warm? Well, that's good.
It's hot today.
And how many of you doubt that the main cause of climate change is human emissions of greenhouse gases? Okay, a couple. So scientists don't have all the data about that. In fact. So I can move on to the, I just have a couple of slides just to set the stage. So the level of warming, especially in the late 20th century, has gotten quite intense. There's obviously some ups and downs, natural fluctuations in climate that happens all the time. Sometimes we have cold winters, sometimes we have warm winters from one year to the next. But the overall trend has been towards warming. In fact, this warming seems to be accelerating in the past couple of years. 2015 broke all records. And the only year that seems to be warmer in 2015 currently is 2016. There's a prediction that's made right here on this little one, and it looks, based on data up until July 2016, it's almost impossible that the full year 2016, let's just say we would need to have the next 3 months to be absolutely freezing for 2016 not to be yet another record. So we're definitely on path toward accelerated warming. And the culprit is undoubtedly man-made emissions of substances that alter the energy budget of the atmosphere. We call those greenhouse gases. The main one you probably heard about, what is it? CO2, carbon dioxide, right? Other ones you've heard about? Methane. Well, I guess they're all, if you know chemistry, you already know part of the answer.
If you could go back to the first slide, I just want to point out one thing.
Oh, okay.
So there's a frequent contention among Republicans in Congress that we're actually in a brief cooling period that's gone on for about 10 years. If you go back to that slide, you can see sort of what they're talking about. If you look at that last last 10 years of data after about 2000. So it sort of slows down. And I think there's some controversy over what exactly happened to slow down this rapid rise that had started before. But as you see, the latest years are going back to the pattern that's actually showing up in all the predictive models. And so that particular objection to the climate science, well, you can see what the answer is. Just not the recent debate.
Yeah, scientists love to be able in a position to say, I told you so. And so when the slowdown started to happen, and all of a sudden a lot of climate skeptics say, see, I told you, it's all bunk, it can't be CO2, otherwise it wouldn't slow down. And scientists say, well, hold on a minute, that's not what it means. It means that we have, just like we have yearly, or year-to-year ups and downs, we also have decade-to-decade ups and downs. And simply what this meant is that there's going to be a temporary slowdown in the rate of warming, and it was going to, at some point, resume. And we didn't have to wait that long, actually. The resumption has begun. And who knows if it's going to be a warm decade, a warm 2 decades, or it'll continue to go up and down, but the general trend is definitely towards warming. So, we know the Earth is warming. We know through a lot of different methods. So we'll talk a little bit about what the paleoclimate record teaches us. The history of the Earth teaches us that, lo and behold, whenever the Earth was warm, you had high concentration of greenhouse gases in the atmosphere. So it's not very surprising to see that, but now we have models that also tell us that unless we put in what we call anthropogenic factors, so man-made influences on climate, we cannot reproduce this 20th century warming. So that's why the IPCC says in its poetic jargon, it's extremely likely that human influence has been the dominant cause of climate change. What they mean by extremely likely is that they have higher than 95% confidence. So this is something that perhaps is interesting to talk about too, in terms of the type of information that science delivers and what policymakers want. Policymakers will tell us, well, I want to be absolutely sure, because I don't want to take a policy decision unless I'm absolutely certain. Think about the number of times you go to the doctor and you ask them, are you absolutely sure of your diagnosis? There's always some level of uncertainty, right? So are we comfortable making decisions with 5% certainty? I would argue that we do that all day long, every day of the year. So it is with climate change. Okay, so here's a little message from the past. Sarah, do you want to take this one?
Okay. All right, so what I wanted to talk to you about was notice that it's warm outside. And that's probably not a very good metric of what the planet is doing on a day-to-day basis or a year-to-year basis, because we tend to forget, right? But we can look into the past and see how it has varied. And so, so today, we live in a world where we have 400 parts per million CO2. And that is unprecedented in recent history, recent Earth history. And we know that what that means by looking further back in the past and seeing what the climate state was like then. Okay, so we can look at the planet today with its ice cap on Antarctica, its ice cap on Greenland, and we can see how the climate system behaves. But if we want to consider a future with the current levels of atmospheric greenhouse gases that we've given it, we have to melt a lot of the ice on the planet. And that gives us higher sea level than today. And it gives us a world that's quite different. So the coastlines are going to be different, the climate patterns are going to be different to today. So we can look at different periods of Earth history, and we can see what happens to the climate system when we do this to it, when we do that to it, what plays out. Okay, so you've got a lot of data on the screen here. You've got temperature and CO2. And temperature is in red, and CO2, carbon dioxide. Sorry, temperature is in blue, carbon dioxide is in red. Okay, so the metronome of these two things are going up and down together. So this is one way that we know that carbon dioxide in the atmosphere drives temperature up and down. We can also do a very simple experiment in a lab and measure that warming, but we can look at how it works over geological time. Climate changes abruptly, and what you're looking at is ice ages. You're looking at the planet on the right-hand side where it's 0, you're looking at the planet in a climate like today, and when it's down the bottom of the page, you're looking at an ice age. So this is a lot of data for you to take in, right? But we come out of ice ages very abruptly. It's another thing that you can see from this graph. So you might need to use a lot of imagination, right? But this is when we're growing an ice sheet, and this is when we're rapidly losing an ice sheet. This is when we're growing an ice sheet, this is when we're rapidly losing an ice sheet. So the danger is when we put CO2 up in the atmosphere very high, that we can melt ice very rapidly. And so we're very concerned that the rate of ice melt is going to be triggered by the amount of carbon dioxide that we put in the atmosphere. And the lessons from looking at multiple glacial terminations here is that this can happen very rapidly. So we could lose ice on Greenland very rapidly, right? So we're watching, scientists are gathering data, right? We've got satellites in space, we're looking at the world, and we're looking at how fast the ice is melting. We've seen it go very fast before. What you're looking at here, every time it shoots straight up, that's when the Laurentide ice sheet disappears. It's the ice sheet that sat on top of Canada. You're looking at the ice sheet on top of Britain disappearing, the ice sheet on top of Europe disappearing. Those ice sheets aren't with us today. In the warm periods at the top of the graph, we've got ice on Antarctica like we have today. And in some of those interglacials, we have ice on Greenland to varying amounts like today. The question is, you can see the CO2, the red spike is going up. We're taking it out of any of those scenarios that we've seen in these last two glacial cycles. We're taking it into a warmer world. So we have to go back further in time to when CO2 was at those levels to see what the climate was like. And we didn't have ice on Greenland, and we had less ice on Antarctica, and sea levels were higher. So we look to the past and we can sort of imagine the scenario for the future. And so it takes some imagination. And so what I try to teach in the classroom is what these lessons of the past tell us, right? So it might sound implausible if you hear a forecast that says sea level will rise 1 meter by the end of this decade. And there might be some uncertainty on that, right? 20 centimeters, 40 centimeters, it might sound like we don't know what we're talking about, right? But sea level will be higher by 2100. Let's say it's higher by about 1 meter. And that might sound a little implausible. It's only gone up 20 centimeters so far over our little records that we've been taking, at gauging stations at coastline. So do we believe the forecast? Well, Julien and I do, because we look to the past and we've seen that sea level can be 4 meters higher, 6 meters higher. It can be 120 meters lower. Okay? So maybe you wonder whether you should buy that house at the beach and whether sea level will be indeed higher at the end of your lifetime, when you get to enjoy retirement at the beach or something. Okay, but in this time period, right here, sea level was 120 meters. So you go to the beach, you walk down 120 meters, and that's where sea level was. So if you can accept the fact, and we know this really well because we can see it multiple times in the geological record, if you can accept the fact that over those cycles, sea level has gone up and down 120 meters as we put ice on top of Canada, 3 kilometers of ice on top of Canada. And then a little 1 meter rise in sea level by 2100 doesn't sound so implausible. So I can't tell you if it's going to be 60 centimeters or 1.5 meters, right? And so climate modelers try to model ice, which is a very hard thing to do, and model how ice melts and how it moves. And they do that, and they spend all that time trying to figure that out because they want to see how fast the ice will melt going forward. But we can see time and time again in the past, like history repeating itself, ice sheets can go very fast. So the question might be, is it going to happen this decade, is it going to happen next decade, that ice streams are going to speed up rapidly? And so we're keeping a very watchful eye. Right? And little perturbations here and there will play out. But we can see time and time again that it happens in the past. So I want to give you some of that lessons from the past that we have, because it helps imagine a future scenario that's quite different to today, because most of us don't expect the world to change, right? It's a normal human trait that you expect things to always have been like they have been. When we think about climate change back this far in the past, it might seem abstract, but it helps us to think about the future. And as you think about climate change as an issue in the general election, if it even becomes an issue in the general election, right? Why might we care? There's lots of reasons why we might care about that. So for example, right now, the Arctic Ocean has a lot less ice than normal. The Northwest Passage is opening up, and people are taking vacations through the Arctic Ocean right now, not in class. They're sailing through the Northwest Passage. That didn't used to be possible. Right? People have died trying to do this. This is a big deal. And then it opens up new shipping routes, and a big Korean company just went bankrupt. The shipping company wasn't making a profit, despite moving all those goods all over the world. And if you can go through the Arctic Ocean instead of through the Panama Canal, that's a shortcut that can help move goods around the world. So these are some reasons why this becomes relevant, right? This world is changing, and that will dramatically change geopolitics as we can go into the Arctic Ocean and drill for oil, as Russia can claim territory in the Arctic Ocean, as those shipping routes open up. That changes things dramatically. So we are living in a changing world, and you might not see it as a problem. Some people might see business opportunities. Maybe you want to take that cruise through the Arctic Ocean, or maybe you want the cheaper goods, and maybe you're going to buy the cheaper goods that come through the Arctic Ocean. That comes through risk. Maybe you're going to go into the insurance or litigation industry that will engage with that. So we all have ways that this changing world, it's going to impact us, and it's happening. And we seem to not change our behavior. So although some of us ride bikes or take the bus to work, many drive SUVs around, right? So we don't seem to be particularly inclined to change our behavior. So these are some of the reasons why it is an issue that we should be aware of. And I really look forward to your questions and thoughts about that. And maybe Jeff would like to add some things about how this impacts within the election cycle.
Wait, I'm not done yet.
Okay.
So I'm going to bring it back to policy in just a second. So there were a couple of things I wanted to point out about this graph. First of all, the fact that it's blue and red has absolutely nothing to do with the election. These are just very common colors. The other one that you see here is that at least for this past 400,000 years, in fact we have ice cores now that go back 800,000 years, there's this remarkable thing that there's natural fluctuations in the amount of greenhouse gases and CO2 in the atmosphere. They don't vary by more than about 100 parts per million. So at the minimum it's about 180, at the maximum it's about 280. And that's a fairly tight range, and you can see that the temperature excursions that go along with that, at least in Antarctica, are about 8 degrees. So that's about an ice age right there. Now what you can see is that on the very right, and I don't know if you can see it very well on the screen, but you see this vertical red line, just like hugging the right-hand axis. And that's what we've done since essentially the Industrial Revolution. It looks, it's almost instantaneous from geologic scales. Even by this metric, which a lot of geologists would consider a fairly short time. What's less than a million years to a geologist? Well, in just a century or so, maybe a few millennia, if you believe some, we've gotten the CO2 at least from this state to, it's now over 400 parts per million. So it's a good 100 parts per million higher than it's been at any time in the past million years. In fact, probably the past 5 million. So this is one indication that we're doing something to the Earth. We're taking the Earth to a new territory that it hasn't seen. You might say, okay, why should we care? It's going to open the northwest passage, it's going to create business opportunity. Maybe it's a good thing. Well, there's a couple of reasons why that's not such a good thing. So we're looking at now the trajectory that the planet's temperature could take over the next couple of centuries. And that's, if we do absolutely nothing, the consensus of models is that it'll warm by something like 10 degrees Celsius over the pre-industrial era. Here you're looking at the changes that happened over the 20th century. They look pretty puny, right? They're on the order of maybe 1 degree. We just warmed up by about 1 degree over the pre-industrial era. And we're in store for probably 10 times. And while it creates some business opportunities, sure, but it also creates a lot of dangers. So what are some of the risks that may come with climate change?
It can make health problems worse, like asthma and heart conditions.
Yeah, so heat waves can do that in particular. Yeah, true. So there's a lot of health effects of exposure to high temperatures. Other things, like there's this one weather event that happened in 2012, right before the last election, actually, that was fairly consequential for the election. Do you remember what that was? Hurricane Sandy, right? So tropical cyclones get energized by warmer ocean temperatures. And in a warmer world, we expect more destructive cyclones. We expect them to break more things as they go along, and we also expect the flooding that they bring about to be superimposed on this low sea level rise that Professor Fikins was talking about. We also expect more droughts in areas that are already dry, like California, right? So there's an open debate right now about the drought that we're experiencing, whether it's man-made or what component of it is man-made. It seems like certainly climate change is contributing to how much essentially the atmosphere is sucking moisture out of the soil, and that there's less moisture available for trees. There's been a massive die-off of trees, and obviously a lot of agricultural problems that have come about with that. So we're looking at a world where agriculture may become very difficult in many regions. We're looking at a world where we could see catastrophic storms become the norm, and we're looking at a world, as you were saying, where heat waves may become more frequent and endanger many people, in particular senior citizens. So what are the options available to us? And this is where it brings back to the policy, because we have to, if we realize that we're doing something that's dangerous to our planet, it's kind of like having a nicotine addiction, right? At some point, your doctor tells you, look, you should really stop smoking. You're going to kill yourself. And you ignore the warnings for long enough until you start coughing every morning and you realize, okay, I should really do something. But what's my allowance? Like, do I have to stop cigarettes altogether, or can I decrease gradually? Well, in the case of climate, the problem is our civilization is so reliant on fossil fuels that even with the best intentions in the world, even if you decided to drop everything right now and turn entirely to renewable energies, we couldn't do that for a couple of decades. So it's interesting to look at what is our allowance. And there's different ways to think about that. The one way is the IPCC defines this notion of dangerous interference with climate. Essentially, by how much do we want to allow the world to warm before the consequences become unbearable to us? And in the Paris Accords, which Professor Sellers will talk about in a minute, essentially, some island nations tried very hard to lobby for 1.5 degrees as the absolute maximum that we could let the Earth warm. But unfortunately, that's not realistic. And the reason is that we've already emitted, we've already burned something like 500 billion tons of carbon. And that's, if we want to keep warming below 1.5 degrees, if we want to be sure of that, well, we've already pretty much exceeded that threshold. So what these bars are telling you here is what percentage of models stay within those particular thresholds for a given amount of carbon. And so if you want to have, let's say, 90% confidence, at least by this metric, that you're going to stay below 1.5 degrees, well, we should pump carbon out of the atmosphere. We're already over the limit. Right? So the next one is 2 degrees, and that's what the Paris Accords set as a target. And you can see that there's a lot of uncertainty. We could be either dangerously close to that if you believe this green bar. If you believe some of the more optimistic models, which are the ones in orange there, maybe we have until 1,000 gigatons. So we can essentially double the amount that we've burned so far. But because we're using carbon at an exponentially increasing rate, it's not like we have another 150 years to do that. Probably just a few decades. Because we're now putting into the atmosphere something on the order of 13 billion tons, over 30 billion tons of carbon every year. So realistically, we have something like a decade or two to really turn this ship around. Or we're going to enter a world that is going to be very unpleasant for us and for many species. So that comes back to policy. Like how do we do that? So I'm going to leave it there. Professor Sellers, you want to take the stage?
Sure. So, let's see, tough problem. And in many ways, it's the biggest policy challenge that humanity's ever faced. When you talk about reducing air pollution, we have some success in some countries at reducing specific pollutants. But when we talk about this fossil fuel-based emissions, we're talking about something that is basically found its way into every aspect of life in advanced countries. And it's the main source of the Industrial Revolution and our prosperity. So we're talking about kind of civilizational challenge, if you think about this on a grand scale. Now, the way that the policy world has tried to grapple with this is actually to take advantage in some ways of the scale of the problem. There's a consensus that there is no silver bullet. There's no single policy you can enact that will be decisive for achieving the kind of reductions that are necessary. However, fossil fuels are involved in so many aspects of society, of the economy, that in fact, there are all sorts of different alternatives for making the necessary reductions. You can develop non-fossil fuel sources of power. You can develop requirements for, say, automobile makers to raise their miles per gallon and create fuel efficiency there. You can just simply put roofs that are more reflective on buildings around the world and actually make a significant impact on the climate. So they've adopted what's called a wedge approach. So you divide the triangle of overall reductions that you need by, say, 50 up into different wedges, and each wedge you can imagine a policy or a change in practices in the economy that would get you that reduction. What we need is some proportion of all the wedges that are possible to get that reduction. So when we talk about what the United States should do, we can talk about it in two ways. We can talk about it overall reductions, which is easy, or we can talk about it in terms of specific policies, which is complicated and in many ways much harder. So there are two things that I want to talk about just to set the context for the choice in this election. First, U.S. policy. There's a kind of expectation that to meet the climate models of making this 2% reduction, so 2 degrees centigrade reduction, we need an 80% cut in fossil fuel emissions in developed countries by about 2050. Okay? So we have a number of federal policies in place that under the Obama administration, and in fact, going back to the Bush administration, despite its opposition to more tougher legislation and to international action, it actually enacted vehicle emission standards that toughened the requirements. We have things like that in place in many different sectors. We have fuel efficiency standards. We have a set of policies under the Clean Air Act to regulate power plants. And in fact, one of the important things to know about the policy context is that it's not just contingent on the election, because the Supreme Court itself has decided that the Clean Air Act requires the Environmental Protection Agency in the United States to regulate greenhouse gas emissions, because the EPA has determined that they are a threat to health and to the welfare of the public. So any administration that comes in will actually be faced with a standing piece of legislation that's 40 years old that they're required to apply in some way to reduce greenhouse gas emissions. Now, the Obama administration had ideas to go beyond that. They were going to set what many economists recommend on top of all the other policies, a price on carbon, using what's called a cap and trade system, where you set an overall target for reductions, which is going to be the 80% that the IPCC talks about for the United States by 2050, and then allowing for tradable permits, and we can go into the details of that policy. But it was very controversial, and it was, although it was a signature initiative of the Obama administration in 2009, alongside Obamacare, it failed in Congress. And so as a result of that, what we have is a kind of mix of things. We have some piecemeal policies that the Obama administration has succeeded in. We have the fairly large-scale regulation of power plants that has now been enacted by EPA, but it's still up for grabs, being contested in the courts. And in many states, but especially California, we have more ambitious policies going on right now. So California is actually a leader in this. We have just recently passed a bill that will require 40% reduction in overall emissions by 2030, which would actually get California not quite to that 80% by 2050, but close. Excuse me, that would be by 2030, 40% by 2030. Now the other thing that's going on here that gives some reason for optimism is actually outside of the policy arena itself, and that is the changes in energy markets. Two basic trends that I think are particularly relevant. One is the fracking revolution. And it has made the U.S. become, all of a sudden almost, the world's largest producer of fossil fuels. And it's because of new technologies that have allowed to open new deposits of particularly natural gas, but also some petroleum in the mountain states and other places around the country. Fracking has actually contributed to the lowering of U.S. greenhouse gas emissions, because it's allowed the energy companies to replace coal or oil with natural gas, which is much more efficient and therefore generates lower emissions. So this is one of the biggest contributors to the overall...
There's a controversy about that.
Well, there's a controversy if you take in the production process and that sort of thing, but you have to factor that in alongside the production process for other forms of energy. But it's fairly clear that it is much better than opening new coal fields or petroleum fields as a way of generating additional production, which is what the U.S. has done. The other thing that's gone on, and it's been encouraged somewhat successfully by the Obama administration in California, is to introduce renewables. The renewable proportion in the U.S. energy portfolio has gone up from 8 to around 12%, just over the last, I think it's 6 or 8 years. And many other countries making even greater strides along those lines. The price of renewables is coming down due to world competition, much scaled up production levels in China and elsewhere. And so there's some reason for optimism, particularly on the renewable side, that at least a dent in the overall emissions can be achieved simply through shifts in the marketplace, people's preferences, new technologies. We'll buy some solar panels in California, even though it's still a little bit more expensive than a lot of other power sources, even with subsidies. Okay, so that's the kind of picture. One thing that has also changed at the international level is the Paris Agreement. However, I, for one, am fairly skeptical about the role of the Paris Agreement in the entire sort of global set of initiatives in this area. The Paris Agreement sets a general target along the lines of the IPCC report, but it has no obligation of any country that signs it to undertake specific reductions. That's one of the ways this is a kind of framework procedural treaty. It kind of sets a baseline for ongoing international efforts rather than it has real teeth in terms of mandating substantive reductions worldwide on the order that is the international control. The other thing about the treaty is it's not actually a treaty from the standpoint of U.S. law. The Obama administration was so confident it could not get a treaty through the Senate, which would require a 2/3 vote in the House in the body with a Republican majority, that they lobbied the other countries involved in the final crafting of the agreement to make it so it could just be ratified by executive action in the United States. So it's actually technically not a treaty, but an amendment to the original treaty the U.S. signed to negotiate greenhouse gas reductions back in 1992. That is the kind of weakness that I think makes this a less institutionalized treaty and makes the U.S. election extremely important. So let's talk now about the main candidates. I guess we do have other candidates, the Green Party and Libertarian candidates. And I guess if you like a full view of their positions, Sarah found a website that was just recently called Statements from the Campaigns, I believe. These are official statements from campaign representatives on what their position on climate change and on energy and more generally on science are. So you can find the positions of the Green Party, Bill Stein, the presidential candidate, the Libertarian Party, Gary Johnson, the other two fourth parties that are competing.
There's some surprises in there. For example, the Libertarian candidate seems to be supporting the EPA, which is interesting because in general Libertarians believe in less governance, right? So that, and the EPA itself has been quite controversial. So that was an interesting surprise. Of course, it's all sort of related, but you can look at their science policies in one place.
Yes, and it's called sciencedebate.org if you want to look online. It's just how it sounds. The interesting thing about the Libertarian Party is that the party platform is actually much more critical of EPA than the campaign is. And so the candidates are to some extent running against their own platform on some of these questions. Let's get to the two main candidates. The Republican Party, as we've discussed, is the home of climate skepticism in the U.S. political system. And if you talk to, say, Republican officials, they're often very careful how they deal with this question nowadays. Partly because the polls actually show that 65% of Americans actually believe in that climate change is a real problem, and a smaller proportion believe that it's human-induced. And so there is a kind of emerging consensus among the rest of the electorate. But in the Republican Party, there are some groups that are actually supportive of climate action and believe the climate science. I don't think it's fair to paint the entire party with the same brush. Mitt Romney in 2012 actually made statements back and forth between the primary election and the general election about his position on climate change. You go back to 2008, John McCain was for climate action. It's right there in the 2008 Republican platform, which sounds a lot like today's Democratic Party platform. So this is something that happened relatively recently in the Republican Party, and it's kind of sort of part and parcel with all the turbulence that has led this year to what amounts to an insurgency within the party actually taking control of the nomination process, with the result that the candidate is Donald Trump. Now, most of you who follow these issues at all probably have seen Donald Trump's tweets on climate change, how it's a hoax perpetrated by China. You probably also heard his denials of those tweets in the last debate repeatedly, which is made for nice sort of media stories, juxtaposing the two. His position in the sciencedebate.org is actually more measured than anything that I see him say in public about this, in that they raise some questions about the climate science. Shall I read it? It's just a brief segment here. There is still much that needs to be investigated in the field of climate change. Going to hire more scientists, I guess, right? Perhaps the best use of our limited financial resources should be in dealing with making sure that every person in the world has clean water. Perhaps we should focus on eliminating lingering diseases around the world like malaria. Perhaps we should focus on efforts to increase food production to keep pace with an ever-growing world population. Or perhaps we should be focused on developing energy sources and power production that alleviates the need for dependence on fossil fuels. So that last statement at the end of the paragraph is actually an indication that the Trump administration could support some bipartisan action to do something about climate change.
It's fine. I was also going to add that he just recently, a few weeks ago, said the opposite and said that he was going to remove all regulations on like emissions.
It's fair to say that Donald
Yeah,
Trump
he's
has
like all over the
always
place.
been on both sides of every issue, so it's hard to know what he really thinks.
But let's talk about the things he's said, because I think if you look at his statements in public that have gotten attention, it's more in that vein.
Mm-hmm.
So what could Donald Trump do if that's his policy once he gets into the White House? One, he could stop the EPA regulatory process. The Bush administration was actually sat on this Supreme Court decision requiring EPA to move forward with regulation of greenhouse gases. So it was only the Obama administration that actually moved forward on it. The Trump administration could essentially retain the current regulations that are being fought over the courts and go back to square one and stay there as long as it wasn't required to do so by the courts. So that's one option. Another option, they could, by executive action only, without any court interference, they could back out of the climate treaty. Now, the climate treaty has just recently gotten enough signatories to ratify it that is going to come into force. But with the U.S. out of it, that's a large player with a large percentage of greenhouse gas emissions, so they would probably have to continue getting more approvals in order for the global climate treaty to be ratified. I think it's actually possible they've ratified climate treaties before without the United States. But it certainly disrupts the process. Third, if we look at the sort of federal system in the U.S., one little known fact is that California's action, which is actually kind of leadership role among the states, is contingent on EPA approval. So California, we enacted our first climate goals back in 2006, but the Bush administration would not approve moving ahead. So it was only under the Obama administration that California was able to move forward with statewide, economy-wide regulations. So EPA would have the authority to, for example, cut off its support for the continuation of California's climate legislation. So not just at the national level, but at the international level and at the federal level, or the subnational level, there are lots of ways that the Trump administration that was determined enough could thwart American initiatives in this field. Now, I guess the other side of it is what would Hillary Clinton do? And it's interesting to look at Clinton's proposals as they've evolved. So the big dividing point between her and Bernie Sanders in the debates and that sort of thing during the primaries was that Clinton was proposing small bore initiatives that essentially assumed that Congress would remain Republican. So she was following along the lines of the Obama administration, which, when thwarted with congressional legislation, started working through the executive branch and focusing on that. So she's proposing subsidies, she's proposing to work with cities and localities, proposing to move forward with the Obama administration's regulations and tighten them further. And she has some big goals, but it's actually small bore policies that she's going to try to use to get to those goals. In other words, what we have under the Clinton administration is probably going to be more of what we have now, which is a kind of mix. The Republicans are probably still going to win the House of Representatives. That's the prediction. It's possible the Democrats could win the Senate. That's where the forecasters have eyed it, that are sort of going back and forth. But assuming Clinton wins the presidency, it's not clear that we will get major new ambitious legislation in the United States.
At least until Congress goes, if it does.
if Congress flipped and you had a Democratic administration, that was essentially what happened in 2009. And they almost, I would say, they almost got legislation through. It actually passed the House of Representatives and died in the Senate. I think in the current environment, there would probably be enough support if the Democrats won both houses of Congress at some point in the near future to have a major national program enacted. And as climate change proceeds, it seems like we might see some of that. But I'm just going to close with one recent study that looked at the United States as it's being affected so far by climate change. They looked at temperatures in different regions around the country, and they found that actually it's getting milder and more pleasant in terms of the weather in most parts of the country. There are shorter winters, people can be outside more, and the researchers concluded from that, well, maybe Americans just kind of feel better off with climate change as it's gone so far. However, if you look, there's a website called CalAdapt, and CAL-ADAPT. It actually downscales the climate projections for cities in California going forward to 2100. And if you look at that website, it shows you things like in Los Angeles, we're going to move to like 3 months of extreme heat days by 2100 if the projections go forward under the high emission scenario. Even if we end up reducing emissions, it's going to be higher, but it's going to be a different world in Southern California if we don't do something. And so I think it's likely that people will end up changing their minds and feeling more strongly about this. There's kind of support, but it's very lukewarm, and it's not the biggest issue for most of the voters. As climate change proceeds, though, I think the sense of alarm will grow. And the real question is, will we do something before it's too late? So I'll stop with that.
On that note, before it's too late, I'd love to have questions.
As the climate science goes, the explanation of scale and magnitude is getting easier and easier for me to understand these explanations of charts and graphs. I think what I would like to see more of is instead of beyond climate science, climate action science. So the idea when you say that we can't cut emissions fast enough, I know that's a political issue, but I'm not understanding the science of how we can't cut it fast enough. So with the wedges that are available to us, how much solar would we need, or how much other types of energy, wind, and what would it take so that if we had a green race or a climate race like we had a space race, what's the science behind how fast we can move, rather than worrying about the politics, so that the public can begin to understand what are the specific wedges that are out there, and what would they start to look like if we were moving faster?
So if I could maybe start and then direct the others to maybe add on to that. So the first thing I'd like you to know is that carbon dioxide sticks around in the atmosphere for a long time. So we've been creeping upwards, and every year there's a seasonal cycle, and now at the lowest point of CO2 in here, because the forest breathing, and now we're at the lowest point, but we're still at 400, that 400 number is now we're committed to be above that for the foreseeable future. The only way to get it below 400 going forward is for us to actively draw CO2 out of the atmosphere. So it's going to take innovation in terms of pulling CO2 out. So technological solutions if we want to get lower than 400. If we want to stay at 400, we have to really pull back our emissions. We have to get to zero emissions if we want to stay at 400. So the longer we dawdle on both of those things, the further up we creep. So we commit to that level. Maybe Julien, you want to add something on top of it?
Right, so there's a simple reason. Like, imagine that you're trying to change all the light bulbs at this university. I don't know how many light bulbs there are, but it's probably in the thousands. And it takes you an hour to change these light bulbs. Well, it's going to take a while before you've changed all the light bulbs. So it's the same thing. If you want to change every single car to an electric car, regardless of cost. But let's imagine that we're in California, everybody can afford a Tesla or something like that. We're not talking about Zimbabwe. Changing all the power plants. Some of these plants are built with the assumption that they're going to function for 50, 60 years. Same thing with buildings. It's sad actually that a lot of the buildings that are built on campus right now are not always built with that foresight of trying to be LEED certified. They kind of do their minimum, but there could be a lot more leadership in heaven because those buildings are going to be with us for 50, 60 years. And so there's a lot of inertia built into the system. That's why I talked about turning the ship around. It really has that type of inertia that if you have a tanker with thousands and thousands of tons of cargo on it, turning it around is not an instantaneous move. It takes a long time. It takes a lot of effort. So, but I agree with you. I love that analogy to the space race. Right now, we're not racing particularly fast, but it would be amazing. Actually, amazing things could happen if we really started to think about it in those terms.
Right, and but the science of how many scrubbers or how much carbon storage or how much, I think that's what is missing in the public understanding of what has to be done, so that they can see what kind of politics and policies they should.
Right, and there is also, I think, once you spell that out, a kind of intimidating gap of how we get there in terms of the economics, the sort of engineering, and the social obstacles. For example, one of the things that there's an article on the wedge approach that talked about the goal of being a 7 gigaton reduction. And there are 15 different scenarios that these engineers, Princeton, came up with that would give you 1 gigaton each.
Yes.
But they had something, they had the kind of scale that's almost unimaginable for a U.S. policymaker's perspective. So one of them was say, reducing the mileage traveled for 2 billion cars, which is like all the cars in the world, from 10,000 miles a year to 5,000 miles a year. Imagine in your life how you can reduce your miles traveled by that much every year. Or imagine how we could even restructure Los Angeles to do that. How are you going to, people are living out in Claremont and commuting in. That's a long commute. And you have to drive around a lot of places in Los Angeles. So you're talking about things that are really embedded in people's lifestyles and the structure of our infrastructure, and so it's hard. It's also hard to see them going on everywhere. I think one of the big opportunities is actually not in the United States, but in countries where you're having rapid development. So if the Chinese and the Indians now are building out their cities, urbanizing the population, if they can introduce some of these innovations, then it will be much more cost effective than ripping out the infrastructure of our current cities as a way of getting major reductions. And that's part of the reason why, in some ways, the pivotal part of global policies is not so much setting targets for reductions, but getting investment in the right places to tip the balance over the longer term. So the places where you are building in these rapidly developing countries, those are the places where it's much more cost effective, where you have green fields for development, where the industrialization is just coming into place, and make it sustainable and give them the resources to do that.
So I think we could keep talking on these topics for a while, but I want to see if there are any other questions out there. You can certainly keep going on this one.
That's a very tough question.
One sort of thing I wanted to throw out there to sort of stimulate your thoughts and your questions is what kind of issues you think should be on the ballot. So these are very challenging issues, right? Most of these assumptions are business as usual, yet most of us want a better life than we already have, right? All your parents probably aspire to that for you. So our consumption is not just business as usual, increases, population increases, but actually increasing exponentially. So asking us to bring our emissions down to 0 is a very big ask. And so it's sort of hard to comprehend that we'll do this, and so we're talking more about adaptation than actually solving this problem. So the extent to which we want to get change on this issue sort of has to come from the electorate, and most of us want to have the life that we're living right now, or a better life. So what are your thoughts? And around the country, do you have different feelings? climate change plays out in different regions differently, right? So in some places it's water and snowpack, like in California, the aquifers. In Florida, hurricane risk, sea level rise. So do you have any other issues in different parts of the country, things that you would like to see part of this project maybe on right now?
Has anybody analyzed what kind of population reduction or population control would be required to, what effect would that have on?
That one sounds like an unpopular
Policy.
So you're absolutely right. That's a big factor because no matter how much we decarbonize our economies, if we do it fast enough and with rising standards of living, we multiply that by a fastly increasing population, and there's just no hope. So stabilizing global population is part of the answer. Now, there's some markets and different dynamics that are already putting that into that direction. As countries industrialize, as the mortality rate drops, typically the natality rate drops. And so we're expected to come in a balance at maybe about 10 billion people. That's what demographers are expecting. But what path we take to get to that 10 billion, and whether it's going to require, climate catastrophe to wipe off 2 billion people, we could get there if we're not fast enough. So essentially, and it's not something that's easy. Currently I'm only aware of China to do population control. It's not something that any democracy could do. So I don't think that's never discussed because that's just not an item of choice. We're just going to have to assume people are just going to reproduce as they see fit.
But I should say, in places like India, there are sort of mandatory requirements, like the Chinese one-child policy. There are ways of introducing birth control.
Yeah, it seems like
all you need
popularizing
to
birth
do is
control can
educate
go quite a ways.
give women opportunities often, and they will reduce their family size.
Educating women is definitely a way. They tend to have fewer children. I have one. There's a question back there.
Yeah, so less on a policy note, just in order to, in an effort to try to understand some of the data better, can you guys explain just on a basic level how the metric of global average temperature is actually calculated?
That's a question for Julien.
Why don't you take my class next semester? 150 climate change. It's not a very complicated thing. I mean, there are some uncertainties having to do with the coverage that we don't have a thermometer at every single corner of the globe. But you can make calculations as to how many sensors you need. And we essentially know this. The uncertainties on this are much smaller than the signal. So we're very confident that it's known. Would I like to know it at thousands of millikelvin precision? Sure. It's not necessary to get to that devilish level of precision to know that we need to do something.
But could you just explain, is it just like a thermometer in 5 places around the world that are just kind of arbitrarily chosen, or what sort of actual methodology is used to calculate that?
So there are weather stations. Actually, in high school, I interned at a weather station, and I read an article recently about how valuable those long-term records are. Right? It's really nice to have a thermometer, even if it's not the most up-to-date. It's really nice to keep those thermometers in the same place, maintaining those very long records. The trouble is that those places change over time, so cities get built up around them. So we have those long-term stations. So California has been collecting temperature data for about 150 years, about the length of the state. And the coverage varies around the world. The British, you might have noticed my accent, we put in meteorological measurements in many places around the world. They then fell out of service later, right? So we've had weather stations around the world in many locations. And at sea, there are buoys with instruments dotted all around the world's oceans for many reasons, because we want to monitor tsunami risk, because we want to see El Nino, and they collect temperature data. And then we have satellites that are scanning the world, gathering temperature data. So all of that information gets layered together. And we get temperature estimates for each grid box. So people go through and clean the data, look for things like satellites, orbits changing, and they adjust for that, right? They look at heat islands, and they would know that the data from the center of London has got to get thrown out. They deal with all of that. So a lot of fact-checking goes into it, and a lot of very smart people are working on it in huge buildings around the country, right? In different locations. So there are many ways of getting at that, and then somehow magically they get to an average. So yes, it does sound a little tricky. I don't think it sounds easy. I think it probably takes more than a GE class to wrap your head around it.
Yeah, there's obviously a lot of stuff that goes into it, but the simple way to look at it is like you have 3 lines on this one, and these are from 3 different centers that looked more or less at the same data and compiled it in different ways, applied different quality control criteria, different statistical methods, and from where you stand, you can probably hardly see the difference between these curves. Right? And that's the point. Especially in recent times, we know that very well. As you can see, in the 1850s, those gray uncertainty bands are pretty big, but there's still no chance in hell that the 20th or the 21st century is colder by any means than the 19th century.
And so this is the average, and that doesn't matter to any of us, because none of us are average height in this room. None of us are having an average experience in USC, right? This is the global average. So it does matter for a few things, like ice volume on the planet will sort of track this. But what matters to you is your experience. So before we came in here, Jack was talking about the extreme heat, right? So we all felt the heat was today, that was uncomfortable. There are a few places on the planet where temperatures are going to get to the point where it's not life-sustaining. But there are places in the Middle East, there are probably places in the desert interior, if you head east of Los Angeles, where it would get to the point where you wouldn't survive for long outside, at least not without a bottle of water. So yeah, the local experience is what matters. It is not just temperature. So temperature is something that we can measure really well. And it's also something that we focus on reconstructing in the past, but there are many other things that matter a lot. Temperature matters a lot in California, okay? So obviously extreme heat is one of them. I wouldn't say it's mild, I would say it's too hot for me. But it matters a lot for our snowpack. So even if we get the same amount of precipitation year in, year out going forward, if we get more rain, even if we get more rain, we get it as rain instead of a snow, that's a really big problem. So just going forward, we had a very thin snowpack in recent years, and that was actually what was projected for 2100. Every year is very variable. In 2100, with no snowpack, we can't dam enough valleys like Yosemite to hold water, right? So we have a real problem of water storage. So in California, it's all of temperature plays into it because that affects our snowpack. And so that's a big part of the climate risk in California as temperatures rise. So it's all about the local experience. In some places, like England, you know, a little bit of temperature rise is probably a pleasant thing in terms of crop production. We can grow wine, grapes for wine. But unfortunately, it doesn't play out as a sort of gentle upwards temperature rise. In some places, it's going to get unpleasantly hot. We're going to pass the point where we get hurricanes and tornadoes, right? So yeah, so the average is, it's a very interesting question, and it allows us to compare the planet going forward and to compare it to climate models. But
I have a question following up on that. How reliable are the downscale regional predictions?
No.
So is this just something that might happen when they give us a forecast for, say, Los Angeles as opposed to Palm Springs, or is it possible it could actually veer back the other way? Because I know a lot of the science sort of points to, you know, excessive rainfall in some places as a result of climate change, more drought in other places. Is there a lot of uncertainty about those kinds of predictions?
Yes, the climate models are good at large scales, they're not good at individual city scales.
And they're better at temperature, right, than they are at precipitation. So models don't rain very well. And that's because it's a problem of scale. So temperatures tend to be large scale features, and raindrops are obviously very small. So it's getting the cloud physics right is quite difficult. And there are lots of variables. But California, as you know, we don't have any rain all through the summer months. We have rain in the winter, and that rain comes in a few storms. So the difference between getting one extra storm and one fewer is a big deal. So even from year to year, we have a hard time with that. So of course, the models likewise reflect that uncertainty as well. And so actually, yeah, it's hard to know if it will get wetter or drier in California, but year to year, it will continue to be variable. And the temperature rise means that we will have less snow, more proportionate rain, which is a problem in itself.
And less moisture in the ground, which is important.
Oh, sorry.
Yeah, go
Oh,
ahead.
sorry. Can or will technology exist to pull carbon dioxide out of the atmosphere?
Yeah, it does. I mean, I don't know too much about it, but there's been a successful demonstration in Iceland recently that has actually succeeded in pulling some CO2 out of the atmosphere successfully. So yeah, it takes a big scale up, but I don't know if anybody else wants to add more on that issue. There's lots of things to try, right?
What about just planting trees?
Right.
That's
So essentially, it's mimicking the idea of trees on a broad scale. I mean, trees need other things to grow, and they tend to be slow. So if we wanted to do this, if we realize, wow, we really need to pull out all these billion tons of carbon in the atmosphere by next decade, and we can't wait, especially with the rates of deforestation, we can't rely on forests to do that. So people are essentially building artificial trees. And the problem is, you know, trees are powered by photosynthesis. You need a power source to do this. So it's you know, you're essentially fighting the second law of thermodynamics. It's a spontaneous process to burn carbon and put CO2 into the atmosphere. Pulling it out of the atmosphere is very difficult. It will require actually energy to do that. And so if we don't have a clean system to produce energy in the first place, it's going to be very difficult. So there's not much point in trying to scrub CO2 out of the air until we have a completely decarbonized energy production system. But once we do, we could do that. So that's the good news, is that if we figure out a way, if you put a solar panel on all of these things, you know, it adds to the cost of the thing, but it's feasible to start pulling out. But again, you know, we also have to look at building things. There's an embedded energy in that. Right? It takes some energy to make things, to make cement, to make steel. So it's unclear. I don't know that anybody has done actually accounting. If you have 30,000 of these scrubbers and they all have a few, you know, a carbon bill of a few gigatons or a few tons, I'm not sure how it shakes out. But theoretically, it is possible, and there are prototypes that are available now.
So the example in Iceland is associated with geothermal heat. So there's an energy production happening right there using the geothermal heat and its reaction with the rocks, storing CO2 out of the atmosphere. So there are some ideas with spreading these reactive rocks through the soils of the world, but you can imagine that that would have impacts on soil microbes and affect food production and all sorts of things. So sometimes there are technological solutions that might have negative consequences, right? So the job is to think through all the complexities of the knock-on impacts of those deployments, of those technologies, putting little particles in the atmosphere, right? Chemicals in the atmosphere to bounce sunlight back to space, right? To cool off the planet, but that might have negative consequences on the world. Thinking about health impacts or other things, or just unintended consequences in the climate system. In terms of planting trees, we can plant trees, but there are plants growing outside, right? So do you say that the desert ecosystem is not valuable and instead we need to plant a big forest of trees and put lots of water that we pull out of the ground? It's not that easy to think. I mean, the planet vegetates itself nicely anyway, and if we make value judgments about which ecosystems are worth preserving, we can magically make a big forest grow in a desert, right? People have talked about this for a while, but that's not recognizing the value of the ecosystem that's right there, and it doesn't pull a whole lot of carbon out of the atmosphere.
In terms of scale, that was one of the wedges in the wedge approach. So we said we could get 1 gigaton of reductions, which is like 1/7 of the total you need, if you ended deforestation worldwide and I believe planted 100 million hectares of additional forest land. So that's a very large scale, and I think one area that might be worth looking at is what kinds of plants have the greatest sequestration possibilities. That is, what kinds of ecosystems would you want to encourage? Where could you encourage them? Where would it sort of fit the natural ecology? And that you could see a policy based on that kind of science.
So there's actually some examples of that. So the Northeast was actually very agricultural, and if you drive around the Northeast now, you see big trees that have regrown. So this is secondary growth of forest on former agricultural land. So that did lock in some carbon into those trees that grew back, but those trees grow, die, decay, recycle, right? So once they've grown, once the forest has locked in that carbon, it's just going to be turning over. So it's not, there's not a whole lot you can do. The rainforest serves a big service. We have in many developed nations cut down on forests. And now some of the forests of Indonesia and Brazil are under threat from palm oil. So if you walk around Trader Joe's and you look at the cookies, or you look at the ice cream, or you look at pretty much anything, you'll find palm oil products. And the thing with palm oil is an agricultural product like any other, except it's grown in monocultures in the rainforest, some of the wettest places that are centers of really high biodiversity. And these countries, of course, want to cut down their rainforest to grow crops that they can sell to export and for their economies. And of course, they have the right to do that because we've forested our forests already. done what we wanted to do, right? But the problem is that these are some of the most biodiverse places on the planet. And so it is a loss to all of us when these forests go. And there are, of course, many environmental consequences for planting very productive palm oil forests, right, in place of biodiverse natural ecosystems.
The Brazilians have made some progress in reducing the rate of deforestation, and that's actually one of their main goals in the Paris Treaty. It's part of their climate plan to cut deforestation to zero and even to plant back. But that's really a rare success story right now in the world of developed countries in the tropics. And Indonesia, I believe, has a very effective program there. That's one of the areas where there's some international action, though, attempts to take investment from developed countries and invest it in protecting tropical forests and high biodiversity areas that would be subject, vulnerable to these kinds of threats. Many of them are actually illegal, according to the domestic law of that country.
Yes?
So this is kind of a two-part question, like on the policy side. How do you think governments can help developing countries prevent things like displacement or refugee crises because of warming? Or do you think it's like a matter of adaptation, or is it preventable at this stage?
Well, that's a tough one. Yeah, so there's some pictures on the slide here. And actually the refugee crisis in Europe right now, so people coming out of Syria, is in large part driven by drought. And of course, it's not just environmental, there's also political reasons why countries are struggling. So I think your question was, what can be done about it, right? Okay. Got any ideas, Jeff? So this is a big problem.
Yeah, I think, as I see it, the problem of refugees and displacement to these environmental catastrophes is maybe the biggest human catastrophe that we can sort of concretely predict if climate change accelerates. And if we look at floods, for example, in tropical storms, the Singapore government and Netherlands, low-lying places that are highly developed, are already planning their seawalls, but we have no plans for Bangladesh, which has had some of the worst problems in this area. And so the developing countries in the international negotiations have increasingly insisted that there be some kind of compensation written into the agreement. It's still ongoing. It didn't really make it into the Paris Agreement. And that adaptation play a greater role. And so I think that's what you will see moving forward as the subsequent iterations of the international agreements evolve.
Thinking of island nations, very small problems to solve, right? Small numbers of people that were displaced by rising sea levels in Tuvalu and trying to seek asylum from nations, and I'm sorry for forgetting the details of trying to seek asylum from Australia and New Zealand, and I forget exactly the details of which one accepted and which one did not. But this is a really hard problem. That's a small island nation, and you can see the Syrian problem on a more massive scale. So yeah, this is going to require a lot of resources and time trying to solve these problems as large numbers of people move around the world. The problem of climate change in developed nations is always much less than if you're in a subsistence agriculture region or a place that's much more marginal or sensitive anyway, where the social structure is less capable of taking care of those issues. But even in developed nations, sea level rise hitting New York City is going to be a big problem. And seeing how Hurricane Katrina played out, even within developed nations, there are some pretty sad stories that occur when crises hit. So yeah, unfortunately, this is a big concern.
Yeah, I think we used to think of climate change as the great equalizer. That this was something where it's going to affect all of humankind, and so it's a collective action problem. We all have a stake in this. But the reality is that the most vulnerable, not everybody is equally vulnerable to it. It's always the poorest and the youngest in the world who are going to be the most exposed. And so we saw that play out with Hurricane Katrina. If it had, Hurricane Sandy, you you also saw that it's in the poor communities that people suffer the most, where the emergency truck is always reaches there last. So that's going to be a problem everywhere. So you're talking about essentially disaster preparedness, and that's not something that societies are terribly good at, even in Los Angeles, where I hope you guys all have your earthquake kit at home, that's supposed to be life in a high-risk place. You're supposed to know how to live with a constant level of risk. And I think in countries like Japan, for example, or Chile, people undergo training, and increasingly in the US as well, for example, there's the shakeout events that you register for since you live in Los Angeles. So on October 20th at 10:20 a.m., there's going to be a simulation of what would happen if there was a large earthquake. So that's an example of disaster preparedness, and that's for one particular type of disaster. That's an earthquake. But I think we should get ourselves ready for a lot of climate disasters if we don't do anything. And that's when it becomes a political problem, that's when it becomes an economic problem, because you often hear, well, the cost of doing something about climate change is too high. It's like, well, is it too hard to prepare your house for a disaster, or would you rather have it all wiped out and rebuild it from scratch? And I think if you put it in those terms, it becomes the cheaper option and the more rational option to deal with climate change up front. That's not the political conversation we're having. Certainly not in this election.
I know that I'm glad to get to my classroom at 9 a.m. if it's nice and ice cold because I don't have air conditioning at home. And for poorer communities, they'll sometimes have cooling stations for extreme heat waves, places for people to go and cool off. And you saw what happened actually in Paris in a big heat wave when a lot of elderly people passed away because they were simply too hot. And the extreme heat can have really negative consequences. There's one that would presumably affect Los Angeles in the future. Is that we might need to have community cooling stations, like schools might need to be open, and they have school closures when schools are not air conditioned. So USC doesn't have that problem, so you've got air conditioning, so you don't get to get out of class.
On a more personal level, what do they do as an individual besides learning and thinking like lifestyle, but alleviate
The answers are always not very nice, right? Because it involves consuming less. That's the simple story, is consuming less. There are many ways you can consume less. You can try not to waste as much, right? That's an impact of quality of life, not wasting. So trying not to be wasteful of things is a good way to go forward. But many of us want to do things and want to own things and want to travel, and those things all take energy. So if you can be conscious in your own life about consuming less, and these things are unpopular, right? It's not fun to tell people don't take that vacation trip and don't buy that SUV. When I bought a car for the first time, gas mileage was high on my priority list. Buying a car that had low fuel requirements. But I ride the bus. So every day I ride the bus to USC, and sometimes I don't enjoy standing in the middle of the freeway waiting for the bus. And riding a bicycle, as you saw, carries some risk. But it also means that you're very healthy. And this is also a positive thing, right? So we all carry risk in every way, but I would recommend that you ride a bike or take the bus to USC if you're a commuter. Those are ways that you can really help.
There's a book that I've gotten to be reading with a lot of practical hints, put out by the Union of Concerned Scientists. It's called Cooler, Smarter. We actually assigned that in my class as a textbook or exercise where we get people to do an experiment, see how much they can reduce their emissions. But there are a lot of practical tips. You can also go online. There's climate calculators that allow you to calculate your emissions, and they also have lifestyle tips attached to that. So if you just enter I guess there's a cool climate calculator or something like that, run out of Berkeley. There's a good one associated with the University of California, Berkeley. EPA has a good calculator, and you can find several others online as kind of resources for personal lifestyle decisions, and it makes a difference.
Yeah, I would say consuming less is definitely part of it, but consuming smarter or in a different way. I think for a lot of us, it's about being aware of the environmental costs of everything that we consume, starting with the food or the water. Why is this wrapped in plastic? Why are we paying for water now? That's another existential question.
Water around.
But trucking water around, getting water from Iceland or Fiji,
PG,
Like,
no.
how ridiculous is that? You know, so yeah, but you have hydration stations at USC now, and you know, yeah, it doesn't taste as good, but that's one way that can make a big difference in the climate equation.
And telling people what to eat is often extremely unpopular. That's less popular than saying you shouldn't drive an SUV, please drive an electric vehicle, right? But meat is actually a really big consumer of a lot of energy and a lot of water too. Yeah, so actually plant-based foods, and I take the bus with the guy who's in charge of picking the food vendors for USC, and they actually think very carefully about like, providing plant-based foods. Unfortunately, in seeds, when they're asked to stock healthy foods, it's by the same 10 people, and people pick the unhealthy options. So,
yeah, so that's one way. That's a very deeply personal decision, right? What you eat. I'm the body type that has a very hard time living without meat, and I've made that choice of only eating plant-based food, fish from time to time. But it's not easy, and you know I do CrossFit, and like the people next to me get huge, and they have like they eat meat 3 times a day, and I just made that choice. But it's not a choice that you can impose on other people, and that one certainly, you know, there's a lot of things that can happen politically, but telling people what to eat is not one of them.
I think there's also a lot of sort of workplace and community choices where there's kind of a role not just for making personal choices, but for speaking up and being kind of activists. So we encourage people here at USC to look at things like replacing light bulbs or putting in these kinds of sensors that will turn off lights in the room when you leave. Those are kind of easy things that can be done. They're often actually cost effective, but many organizations and institutions just need the extra push to replace with more sustainable technology when they have a chance. And so this is one thing that I sort of insist on is going into sort of professional life and law firm or business. Businesses and organizations are also going to be the cost if something is to actually be done. This is something that all organizations, all societies really follow. It's not just a matter of policy.
I picked where I live based on the bus route, so I live along the bus route to USC. And when I was in college, I was riding around like bicycles, like many of you. And on the weekend, actually I choose to get around that way. And sometimes when you have a kid and you settle into routines, there's a temptation to get in your car. But we bike to the grocery store and bring back. We go to the grocery store often. We change our pattern. It's a family activity. We go to the park and we take all the baseball gear on a trailer behind. My husband has an electric bike in his commute, and he just put 10,000 miles on his electric bike in 3 years. So he just, we just went down to one car, and that car stays parked in the garage for just the odd occasions when we need it. So, yeah, and it's actually fun. It's a fun part of life, and it makes you healthier as well. So I think there's more room for optimism in that. There's a professor, Matthew Cohn, who Blue Skies Over Beijing gave a talk recently, and I think there's a lot of room for optimism in China. There's a lot of coal-fired power plants that are polluting a lot, and this leads to bad air quality, and there's really bad air quality in Beijing. There used to be really bad air quality in London. My grandparents' time, they passed air laws just like they've passed air quality laws here. And because we're all motivated by our own health, there's actually some optimism that people will do things about it. So we do move to cleaner technologies, and at the same time usually burn less fuel, but there are more of us and we're wanting more. So sometimes it's not, the change is positive, but it's not really a solution. We're still burning more fossil fuels on average. So there are more people, we're consuming more, so even though the technologies get cleaner. So it's sort of, we all want more, and that's a hard one to fight, right?
Yeah, I guess we're out of time now, but there is some reason for optimism. I believe the last climate figures that came out for 2000, the last emissions figures worldwide came out and showed that for the first time, global emissions had not risen in a period of economic growth. They actually fell in the Great Recession, but that was because economic activity fell. But now we are actually seeing a sort of tick downwards in the emissions rates due to all that's going on around the world. And so it's theoretically possible, and it may even be practically possible over the longer term to see the kind of change that's necessary.
I'm going to leave you with one thing that doesn't necessarily require political action, which is market forces, right? Left to their own devices, if the economics of renewables are favorable, you don't need to do anything politically. The market can take care of itself, right? And that would be the platform of the Libertarian Party, for example. And to some extent, it was the platform of the Republican Party. They were the ones who invented cap and trade for solving a different problem, that was acid rain in the 80s. And so that was actually, I think, in the 90s when it was enacted. So President George H.W. Bush is the one who enacted a cap and trade legislation. So it's a market mechanism to solve a particular environmental problem.
Bipartisan.
And it had broad bipartisan support, so it could happen again. But how do we change the economics of renewables? How do we make them, a win-win? Well, one reason why they're currently when fossil fuels appear to be cheaper is because there are some massive subsidies for fossil fuel companies. There's big tax breaks for ExxonMobil or companies like that, Chevron, which are already some of the highest earning companies in the world, and they also have the nerve to ask for taxpayer money for prospecting for resources. And it's hard to get a handle on these numbers, but it could be in the vicinity of $100 billion a year worldwide. So I think if we took those $100 billion a year from oil subsidies and put them towards renewable energies, you would see the balance tip quite fast. So that's something that politically you don't hear any candidate, even Democrat, talk about that, because I think all of the politicians have a stake in this. But that's something, as a voter, you have power. You can ask those uncomfortable questions at town hall meetings, and I encourage you to do that on forums. And I think that would be a low-hanging fruit. You remove oil subsidies, all of a sudden, it's going to change the economics of renewables, and we probably, maybe it'll alleviate the need for a carbon tax or cap and trade.
Okay, so we're pretty far over time right now, but we appreciate everybody's interest